Hey everyone, welcome to this webinar. Topic is automated Azure monitoring with artificial intelligence. On the call today, we've got Marius. Marius is AIM's CTO, and myself. My name is Ivar. I'm the CEO of AIMS. Today, our intention is to spend maybe about 5 minutes on a handful of slides to set a little bit of the stage, and we will spend most of the time doing a live demo. That's going to be a little bit between the two of us, and we are leaving 5 minutes at the end for Q&A, so feel free to submit any questions in the Q&A pane. Also be aware that this webinar is being recorded, and the recording will also be shared and also be published on our website. And participants are by default muted. So what is the promise of this webinar? So AIMS is about automating monitoring, and that's because traditional monitoring fails in a modern IT environment when systems and IT applications become more complex, more agile, partly due to connectivity between applications and the external world and potentially complete supply chains. Elasticity is also coming into this picture, especially with the cloud and Azure, which we're going to speak about today. And Azure is no different from any other modern IT application, and the challenges and resources and metrics that you need to monitor with Azure explodes. So, and especially when you start introducing microservices. Further, Azure is dynamic, often in a way that deploys of code deployments and integration is quicker and more agile development processes as well, and less waterfall. Containers is being used a lot more, and scaling can be set to be elastic for microservices especially. And when things are getting elastic, cost is also an important part of monitoring. And of course, these systems are now interconnected. It's not silo applications, that's monoliths that you have control of in your local server sitting in your local data centers. So what we would like to present today is what if a solution could deliver a comprehensive monitoring across all performance metrics, billing for infrastructure application containers and microservices in Azure, and further have them automated, removing the traditional monitoring manual labor that's typical for setting up and defining static thresholds, alerting scenarios that typically end up only covering a very limited part of the monitoring you need, and also making sure that you actually can get that done in a very quick time, 15 minutes, and I think you can do it even faster with AIMS, which again provides insight that lets you operate at what we call the speed your business require, so in a more agile way, free up your resources to get more done, remove the manual work that your employees can no longer anyway succeed with traditional monitoring. And in our world, this looks like really three sort of pieces of a cake, where the first part is really about auto-discovery. And auto-discovery here is identifying the resources in your Azure subscription or resource groups or environment. It's about auto-capturing performance data, and for that sake also billing data. So identifying what should be monitored and capturing performance data. The second part of that automation is about self-learning. So how can you understand which parts of the resources that you're using in Azure are actually communicating, interacting, and have some sort of dependencies? Because that's going to be critical for you to understand when something happens in one microservice or load on the CPU on a VM, how is that going to impact the rest of your applications that's maybe exposed to your customers or through the supply chain, through some logistics, for example. And also understanding what is the normal behavior of performance data that you capture. So the only way to be able to monitor the complexity and the scope of performance metrics that you need to in these kind of complex environments is to use machine learning to learn what is normal behavior, because you're moving from a few, maybe some tens of performance metrics to thousands and maybe tens of thousands of performance metrics to keep the necessary monitoring scope in control. That again drives anomaly detection. So identifying, automating anomaly detection that gives you insight into performance bottlenecks that can bring down your business, and also dashboards. That's often quite important. So what we built at Aims is pretty much a unique data processing pipeline, which is SaaS hosted. You can go to our website, create your account without any interference from anyone from sales. I'll show you the URL and then the landing page for that in a second. And what we built is everything which is in this orange box is an automated pipeline where we consume time series performance data from from 200 plus technologies, and it's probably a lot more. That data is being normalized or aggregated into time series, which we apply machine learning and artificial intelligence to understand relationships between resources, and also to automatically detect anomalies across all the performance data. And this output is presented in a graphical UI, which we're going to do a demo of, which for customers is really about getting early notifications to identify problems in solutions that can bring down critical services that you rely on for your profit and loss, basically. Dashboards is governance, and knowledge is really about understanding what's really going on. So in addition, or as an alternative to relying on visual diagram, which are static, topology discovery allows you to understand dependencies between different resources using machine learning algorithms. So with regards to Azure, we are relying on the Azure Monitor API, which Microsoft exposes. So connecting Aims to your Azure subscription or any resources that you want to let Aims have access to is simply a configuration issue in your Azure portal. It's a simple configuration issue in Aims after you create an account.
Perhaps just worth mentioning, you can further enrich that data with additional agents, like on virtual machines. You can install a dedicated Windows Server agent on a SQL server, for instance, that's running on a VM. You can also install a SQL agent. So yes, we do the Monitor API, but you can further enhance the monitoring by installing dedicated agents, or you can also, of course, do custom monitoring if you'd like to do that.
Mm-hmm. Super. Yep. So I promised to show, first of all, a landing page. If you want to kick this off and try this out for yourself, this is the URL, aims.ai/Azure-monitoring. There's a little bit of marketing literature here, but you can easily click sign up, fill in your data, and submit, and you will be forwarded to a page where you actually create your login to Aims. And from that point, you get information about install guides and how to get going. So what we have here now is a playground that we use. So you can see here from the URL, this is a staging environment that we play with. So this is the latest code base. What we're seeing in this sunburst is Azure agent. So I hover here, I can see the Azure agent is connected. So let's say Aims is also a solution that can monitor SQL servers sitting physically in your data centers, Windows, technically anything using Telegraph or Prometheus or open source agents. But in this case, we've connected Azure. If you have multiple agents, you see multiple different systems connected here. But for this case, it's Azure. And we can hover here and see what kind of resources we're monitoring. So we're monitoring disks, we're monitoring storage accounts, public IP addresses, network interfaces, server farms, function apps, VMs, sites, and so on. This is again presented in this overview. It's kind of like a summary. What is important here is that Aims use something we call, I touched on it a little bit earlier. We learn a normal behavior of performance data. So if I now go into these virtual machines, I can drill down and take a look at the virtual machines I have connected to Aims. So I wanted to show you a little bit this. We're using Influx as a database for time series performance data. So let me go a little bit into and take a look at that Influx. So this is the performance data we fetch for that Influx. So as an example here, we can take a look at network as an example. And when I bring up network, I can see a blue area here. And the blue area is the learned behavior. So if I go over to 31 days, I can see that, okay, so AIM starts learning after a period of time, and then these corridors will start populating. So back to the auto part about discovery, AIMS will discover any resources in your Azure subscription you're giving us access to. And then we will fetch all performance data that is being exposed through the Azure Monitor API. And we will automatically build these normal behavior patterns. And these will continue to develop based on what we learn. So which means that for every performance data, for all your resources in Azure, we're building these normal behavior patterns. And these normal behavior patterns are the basis for alerting. So instead of hiring more people to IT operations that needs to set static thresholds for a bunch of different potential alerting scenarios that typically IT no longer have any control of, we apply machine learning and AI to automate that process.
Yes, it's worth mentioning as well that we have more baselines than what you're seeing here. That's going to come in a update in not too long. We do actually have 3 baselines. So what you're seeing here is the core baselines. Then we have 2 additional baselines covering different frequencies of data, and it's a lot more information in here that's going to be visible for the end user in a short time.
Which basically means that if you have data which partly could be a little bit batch processing and a little bit more kind of like more cyclical of nature, you will be able to cover any kind of behavior independent on what kind of if it's spiky and batchy or not. So that is embedded in the algos. So on top, so if we see a deviation of actual performance, which is really the yellow line here, that's the actual performance of network in for this influx VM. If that spikes outside of the corridor, there's a bunch of algorithms that trigger in to consider how big potential impact this deviation or anomaly could have. That could trigger an anomaly, and depending on a number of anomalies that you have on a resource, we are scoring every single resource in what we call the AIM score. So we have a score for every single resource connected to AIMS from 0 to 100 as being calculated in real time. So 100 is perfect, 0 is super bad. This environment is pretty, there's a lot of testing and stuff being deployed here on a pretty frequent basis, which means that 58 is a pretty low score. And you can see that from hovering this sunburst. So if I go down, for example, on these VMs, I'll see that 8 of them are in unhealthy mode, and I can actually see those which are in unhealthy mode. And you can see here anomalies. So I see anomalies, critical anomalies, medium anomalies, low anomalies on these specific nodes in Azure. So all of these are VMs, as we were looking at, and I can dig in and see more details. So for example, I can look at when these anomalies were triggered, and they were triggered on disk write operations per second, 11th of November at 11:26. And I can go further down to investigate this in more detail, for example, by diving into the details in these pages, the performance.
Yeah, here we also use the multiple baselines to classify how serious an anomaly is. So if it's within the core baseline, if it's in the secondary baseline, if it's outside any baseline, and how far it is away from any baselines at all. So all of that information is part of setting the criticality of the different anomalies.
Yeah. So when your team deploys anything new in Azure, this sunburst will automatically update with any new resource types or new virtual machines or new function apps being deployed. This is going to increase. This number of metrics that's being monitored will increase. So currently we are monitoring 1,330 metrics for this environment in real time and capturing and learning and identifying anomalies and triggering alerts. The overall score for this environment is 58, but you see by this coloring of the sunburst that there's a bunch of resources that are red, which means that they're even worse than 58. So this gives a typical user like me, which is not necessarily the most technical, an overview of what's happening in this Azure environment that could, that's abnormal, that may need some investigation. So with that, I think I'm going to hand this demo over to you, Marius, and I'll let you show this from a little bit from your perspective, how you work with AIMS and how you use the different tools.
Yep. So let me know when we have switched.
Yeah, we have.
Good. So it's not so much about the way I'm working, but it's to show a different angle on how you can approach the same information that Ivar is showing. So this is from a so-called topology. We do have 3 different topologies that are automatically generated. We have a physical topology, which means it's a physical representation, a structure coming from the different agents that you connect to AIMS. And in the Azure case, as we can see here, and which we'll go a bit more into, we can see that it's structured around an agent. And then the next step, the next level, so to say, is the resource groups. Then we have something called nodes topology and systems topology, and these are topologies that we'll touch on during this. So entering the physical topology, it's almost the same information as you got from the view that Ivar was showing. On the top here, you can see a green bar gradually going down. That's the AIMS score. And then you have a distribution of some nice colors, red, orange, blue, and green. And it's the number of nodes or metrics in total that we're monitoring and the distribution of anomalies between them. So we can see that for everything that we're monitoring in Azure, 393 metrics are having some serious anomalies, 72 are having medium, 113. No, it's the opposite. 393 are serious, 72 are medium, 113 are low anomalies, and then we have 463 metrics without any anomalies at all. So that's the information that you basically can see on any level using the physical topology. Trying to replicate what Ivar was looking at. So in this case, we are going to enter a resource group. And as far as I know, that influx database is sitting within this resource group. So I click this one. And I know that this is a virtual machine, so I need to find virtual machines, which are currently not in here. So let me try to add that. So this as a node type, Microsoft Compute virtual machines. I add this here, expand it, and I can find the same node as I think you were looking at, Ivar. Is that correct?
Mm-hmm.
Yes. Yeah. So I'm not going to go in and look at metrics. That is something that Ivar has already shown, but I'm going to show something that we do, which is called correlation. So for every metric that AIMS is consuming, we're also correlating these metrics. And the reason that we're correlating all these metrics is to find relationships between different components, systems, applications, and so on. So without doing any transaction tracing, we can actually see what kind of components, applications, and systems that are depending on each other, just by analyzing how the data is performing. So if I go in here now and view nodes, I get a bit more information about this virtual machine. I can see the number of anomalies once again, and I can also see something that's called groups. And in short, that's a correlation group. So we group together components that kind of belong together that have dependencies. And by clicking this icon, I can see everything that this influx database is correlated towards. What's depending on it, and vice versa. And I can see that there's storage, I can see there's server farms, websites, caches, other VMs, etc., etc., etc. It's 60 nodes in total, spanning, I think here, multiple systems. Yes, at least 3-4 different resource groups, as we can see here. And by clicking on these, we can go in and see, if I do it like this, I can see any resource group that we currently have in AIMS or that we're monitoring. And I can see correlation also across the resource groups. So AIMS production is a resource group, AIMS EUN is a resource group. I can just choose to hover them and I can see how they're correlating. What we're going to do now, so these correlation groups are used in anomalies and alerting, because when we have anomalies on a single application or a single node, it could be an application or a virtual machine, for instance, in Azure. We already have calculated what's the dependencies, what's depending on this virtual machine, how is it going to impact anything, and that's something that we use for alerting. So, Ivar, do you want to show that?
Yeah, sure. Let's see. I'm not sure.
Or should I just click it?
Okay, please go ahead.
Will do. So we can see here, I think you mentioned that we don't ship out alerts for every single anomaly. So an anomaly can happen on a single metric, on a single node, and it depends on how we detect that anomaly, if it's a serious anomaly, if it's a low-class anomaly, and so on. We could, of course, send out an anomaly if it's a serious, or if it's deviating highly enough, or if it's classified as a serious anomaly. But we have rules for that. We can get back to those rules a bit later or in a different sessions. But we can see here, let's take this alert here, for instance. It consists of 15 nodes in total. And if I choose investigate, we can see which nodes are part of that anomaly. And this group is based on what's correlated. So we are not just picking nodes here on random, but this is all based on mathematical correlation of how the different nodes are impacting each other.
So, Marius, so let's take an example. And a few of our customers are in the retail space, and we're coming up to Black Friday and everything with regards to shopping ahead of Christmas. So let's say you have a system, some web shop, right? On a web server interfacing probably some payment systems, some order confirmation, some shipping information, and so on. The correlation topology, assuming that we're collecting data from all these kind of resources, will group these resources into correlation groups. And if we have an anomaly in usage or in, let's say, latency in processing data, for example, or confirming purchases increase, triggering an anomaly will be shipped. And the nodes that would be a part of that anomaly would be all nodes that belong to that correlation group that has something to do with web or e-commerce process, right? That allows you to understand which part of the system could be impacted.
Exactly. So in this correlation group, for instance, as you say, they belong together. They could potentially impact each other. Not necessarily all these nodes do have anomalies, but they could have, depending on how big the impact is on the nodes being correlated or working together.
So take that example a little bit further. And so let's say it's a database sitting somewhere that's actually having the performance issue, not able to handle the number of transactions coming in. You could technically see that, okay, this is the e-commerce process, and the anomalies are actually on that SQL server. Technically, it's that stored procedure on that SQL server that's actually having a performance issue that impacts revenue or purchases on the website, right? And that, I mean, the same kind of setup you can do in any kind of industry, if it's healthcare, if it's
in the case that you're mentioning, so we could be monitoring the website, we could be monitoring the SQL in the background, we could be monitoring the application that does the logic. And if something starts happening, as you say, on some transactional detail or level in the SQL or in the database, we could then, of course, also automatically detect how this impacts the application with the logic or the front end on the website. If something starts slowing down, if it's impacting the end user, if the application is not able to, or if the requests are going slower, if the response times are slower and stuff like that. So all of this is like pre-calculated already. We know the dependencies between the application, the SQL, and everything, and we will start monitoring all these dependencies automatically and alert if this grows and escalates.
Yeah, and I think that probably comes back to a fundamental difference between what we do and many others, is that we are not monitoring in silo. We are collecting data across any facility, data center, public cloud, or whatever. This webinar is focused on Azure, It's one thing to connect, but technically this could also be a physical server sitting in a different data center or a different public cloud.
And also important, I need to remind everyone about that. We're not doing necessarily transactional tracing. You don't need to instrument anything or do open source tracing or anything. As long as we have data, performance data, transactional data, whatever kind of data, we're going to correlate that data and find patterns and dependencies between the components and systems and applications. And you will also get the value to say how sure we are that these two systems are actually interfacing each other. So it's a correlation coefficient, as we like to call it. It's a value between 0 to 1. And the closer that value is to 1, if it's 1, we're 100% sure that these two systems or applications are interfacing each other or depending on each other, and so on. So this is all automated. You don't need to do anything manual setup or anything as long as you have the data.
So what would you do if you didn't have this insight through the correlation topology? What's the alternative way of getting that insight?
That's a different webinar, I think. It's a longer manual setup. It depends what you want to monitor.
Okay. Anything else you want to cover in this demo? I think we've spent the time we were planning to.
Yep. No,
I have a few slides, kind of like wrap-up slides to go through.
Yeah. No, I'm good.
So shout if you can't see my screen, Marius, but live demo is done. So a little bit kind of like wrapping up. The fundamental pieces of technology that we have, which is I think is completely unique in the global market, is that we're able to identify the relationships between different resources for this purpose in Azure, but it could be any source. So topology discovery that identifies the relationship and dependencies between anything, including infrastructure, applications, and services across data centers and cloud. And then the second part is really about the normal behavior patterns and the ability to identify anomalies across thousands of performance metrics out of the box, where you typically see alternative solutions in the market will operate with golden KPIs, golden metrics, or where they may be applying some machine learning, which are very limited in scope, or you're relying on setting static thresholds across whatever you define as critical for a business, which is super hard.
Just want to mention one thing. So we're coming from the world of transactional tracing as well. We've been doing a lot of BizTalk monitoring and transactional tracing there. We're able to replicate exactly the patterns that we're doing by tracing transactions through the BizTalk with this mathematical model. So that was one of the goals as well by developing this technology. We could do the same thing as transactional tracing. So without doing transactional tracing, by tracing individual IDs through a middleware, for instance, we can achieve the same result on the same topological map that we created previously by applying these models and mathematics that we're doing here.
Cool. So a couple of marketing things to wrap up. If you're interested to learn more, we have this guide to future-proof Azure monitoring, and this is not only about AIMS, it's also about what kind of tools you can use from Microsoft in Azure and different kind of monitoring tools, tapping into the Azure Monitor API. But there's a lot of content in here which you may want to consider. This is the URL. You can easily also add your email and to download that, but the full paper is available on that website. And if you're interested, this is the web page where you can get up and running. AIMS is, we provide also something we call the AIMS Community Edition, which is a free forever solution. So don't hesitate to test this out on your own. And unless you want to, you don't have to engage with anyone in AIMS. You're fully free to test this out and play around with it on your own. So with that, I think that's the last part. So I guess, Ekaterina, are you still there? Do we have any questions for the question and answer session? Are we?
Hi, yeah. So for the moment, we do not have any questions, but if the questions pop up, please just contact us directly and we will answer them And I think,
Okay.
yeah, I would like to
Great
thank
that
everyone.
everything is understandable.
Yeah, or maybe we will get some questions so we can have another webinars. And please, if you have some other ideas what you would like to learn, let us know, and so we will arrange the webinar around this topic.
Hmm.
Okay.
Very good. Thank you, guys.
Bye.
Thank you all. Cheerio.